Sir, I'm audible now to you, Srivastava sir? नहीं आ रहा सर अभी? हाँ प्लीज सर, आप कुछ बोलिए, मैं फोन पे बात करता हूँ, पूछता हूँ सर से आवाज आ रही है क्या? Am I audible now, sir? Srivastava sir? Sir, now you are audible. Yes, sir. Yes, sir. Yes, sir. You are audible, please.
Okay. Good afternoon.
Welcome, sir.
Some part of your inaugural functions. I'm really happy to join the inaugural session, and I would like Manmohan Gar and also the of Jaipur for organizing such an important training program on energy management in DC microgrid for EV charging. So, as you know that because of the environmental pressure, there is a more renewable, and also there is an energy transition taking place in the transportation sector. We are moving from conventional fuel-based vehicles to electric vehicles. Is targeting to reach a figure of about 30% electric vehicle in coming 4 years, and we already have about 30,000 public stations. Apart from and about 9,000 are charger and about 21,000 the slow charger, and you know the fast charger ratings are about 50 to even higher kilowatt rating, and if every such outlets, how much power they are going to consume. and we want to reach by 2000. So pressure on the grid so maybe in the range to 500 kilo. So what is the solution actually? So one solution is go for local grid, which can be either AC or DC grid, and AC grid becomes natural. You may go for fast charger, which is being operated at DC voltage. So DC microgrid may be set up, connecting to and other resources which are locally available. Now, optimal utilization of such installation will require a proper energy management to be placed. So we call it energy management system. So that will relieve the grid to go for getting stressed. That will really help. So I feel that this topic is very important. There must be a lot of lectures. My own lecture is a very general lecture because that is the first lecture, introductory lecture. So with I again want to congratulate the organizer, Dr. Garg and Academy for wonderful topic they have selected. Thank you very much.
Thank you, sir, for your gracing words. Now, I'm very much thankful to you that you kindly agreed to grace the occasion, being chief guest and the first speaker for this FDP. I sincerely thank our director, sir, Professor N.P. Padi, sir, for providing constant support and the necessary infrastructure for this FDP. I'm thankful to Mighty for providing the financial support to conduct this FDP. I extend my sincere appreciation to the Chief Investigator, AICT Academy Professor Vinit Saula sir, and the team for providing their continuous guidance and valuable support throughout the planning and execution of this FDP. I'm thankful to all the participants who have registered for the course enthusiastically, and we got overwhelming response from different participants. My sincere thanks goes to entire team of EICT, Amanati Jaipur, and my research scholars who have been working hard for this conducting this FDP. Now we shall proceed with the day 1 technical session, beginning with the keynote inaugural lecture by Professor S.C. Srivastava sir. Sir, over to you. Welcome. Thank you, sir.
I hope you are able to see my slide.
Yes, sir. Yes, sir.
So good afternoon again. This is the first lecture, so it will be little general about the power scenario and then what is microgrid, types of microgrid, AC versus DC microgrid, what I'm going to. And I'll also tell about some of the field implementation board. In few of microgrid, I have been in the capacity. So of my outline, I said, giving some this talk about AC as well as DC. Note that city use full-fledged power system started in 1882 was a DC microgrid. Visible to Sora. Visible to others? Hello, is it my screen? Can somebody?
Sir, yes, sir. Yes, sir, it's visual, sir.
By Edison, a system which came to work in 1882, and one of the street of need provided incandescent lamps with 50 customers. So the DC generator was invented by that time, and then 110 volt DC system was set up. And when first I saw the lighting, I just give a dark. and you are seeing lamp in the street. Everybody, it looks like a pearl. And after that, AC was coined by Westinghouse, and finally, globally, AC system was adopted. Cities, Lab, Prayagraj, and Varanasi, where I am, early system was. Then they switched over to AC, and our fans used to have that carbon buses, which runs on AC as well as DC, because some city part was DC and someone was AC. So subsequently, again, it was small geographical areas, so microgrids were formed. And mainly in the areas it was. Now became more popular and for interconnected systems, and now highest voltage in AC is 1100 kV, which in Russia and China has gone voltage 500 as well 100 kV HVDC. So power transfer, it is still popular, but it's developing actually. Now renewable popularity, renewables getting popular, the need of being remote area where normal line cannot go, community electrification, with a lot of village hamlets get electrified. Resiliency concern, like you are worried about some cyber attack, so you want to sustain the system to the extent possible. So microgrids are being. Why the renewables are becoming popular? To address the environmental concern, and everybody is talking. See, what does it mean actually? So net zero means that whatever greenhouse gas you are of the generation on the greenhouse gas. That is the meaning of net zero. Any carbon dioxide measures to cap. So that net. Now, as per one of the predictions, temperature rise to 1.5 as compared to pre-industrial era. Pre-industrial means late 1800. Then a lot of chaotic changes in weather will see that. And right now, people say that we have already reached 25. So the international bodies like IPCC and UNFCCC is meeting in Friday. Emission has to be reduced by 45% in 30, and everybody should reach net zero goal by 50. But India said, I am a developing country, so we will meet this requirement by 2070. Remember that energy sector, which includes power as well as the transportation, contributes to almost 3/4 of greenhouse gas. So there is a need to go for cleaner kind of solutions. Now, 107 countries, still 24 had this move. Many of them, they have already brought the act, or they are in process of implementing. Now, there are many other reasons why it is popular. That prior pricing is, and then we have now very strong power converter and ICT infrastructure so that we can monitor and connect very easily. And ARENA actually international renewable body, which has brought out a report that how this net zero goal will be met by 2050. Electric sector suggested certain measures. As I told, prices have drastically gone down. So compared to 2010, 20 price, you see, 85% is of the Then concentrated solar PV has gone down by 60%. Wind has gone by 56%. This shaded band you are seeing is energy from conventional sources like coal. Now their cost of energy has become cheaper as compared. So this is all the reason to go for more installation of these kind of. Now, as Irina suggested that you have to go for renewables. Some of the renewables have very variable output like solar and wind, variable renewable energy. So by 50, in terms of capacity, we should reach by 92%, which includes large hydro also. But variable energy should reach by 74%. This is the global picture. But we need money to install. Now coming to, you should know about India. This is the latest figure which CA reports, Central Electricity Authority reports every month. And this is December figure, December 25. So total installed capacity is about 514 gigawatt as on that date. Coal is contributing 44%. Renewables, which excludes hydro, is 40%. If you include hydro, it is more than 40%. And then this is the of renewables. Solar is growing very fast in India. We have cities across the country. We are already fifth in across the world, 54.5 gigawatt. And then small hydro we have to exploit, and biomass also to exploit. So this is the generation scenario in terms of installed capacity. Now, since coal is very high, percentage is high. We are being seen as one of the contributors to the greenhouse gas.
Yes, sir, you're audible.
Audible now, sir. Yes.
Audible?
Yes, sir. Please share slides, sir. No,
Not
sir.
yet,
My some issue. Okay, I'll again.
No, sir. No.
No,
Hello?
sir.
It's visible now, sir.
This is the power structure in India. We have grid operators, Grid India, which was earlier called as the PASOCO, and level we have load dispatcher. There are three power exchanges in India. So they facilitate purchase of power through electricity market. Day ahead as well as the real time market is there. So that is the structure. Now whole country is to 5 grids. The reason that we have different type of resources in 5 various regions, like north is having runoff river, large, very weather sensitive. Northeast has high hydro potentials, but mountainous terrain. Our evacuation, because you see here, this area, which one side is Nepal, other side Bangladesh, Bhutan. Land a large number of. So we need to go for either higher voltage AC, that is 1200 kV, or these two lines can transmit about 6,000. Then different. And then poles are in eastern region and renewables in western and southern region. Southern region has renewables, wind, solar, both are. So they will interconnect. It is a grid. 31st December 2013, it became a single. All regions are connected by AC line. So we are operating at single. We are on transmission network to connect them and also internally connecting them. You see that 220 kV and above, we have about 500,000 circuit kilometers. Transfer between regions, if you calculate, we have capability of 120 gigawatt. There is a still chance to improve. So that is how we are. That is about India. We also have connection with other countries like Bangladesh, Bhutan, Nepal, Sri Lanka. Not very interconnected, but like 1160 megawatt and so on we have. I have April 20. But we are planning to enhance it gigawatt of it. Distribution is a lot of problem in the past. You may be knowing very high. In some of the cities, it was as high as 40%, 50%. And overall, it was 23, 24, which has brought down to 18, 19. But we are targeting in a single digit. Our new election document have been circulated. They want to bring it below 10%. We had very high failure of almost 6% in the cities. Really high, it should be fraction of. And reason was that we had no way to monitor health, that whether overloading has taken, metering, customer focus was not there, and then so looking at concepts are being brought up, and government of India has they started with accelerated power reform program, and then they revived APDRP, and focus was scheme was launched, integrated development scheme, where they wanted to strengthen the network, metering everywhere up to consumer. A lot of IT enablement was done, and for rural area, it was there. So they launched UGJ5, Deen Dayal Upadhyay Gram Jyoti, under which the with rest feeders, and then sub-transmission rural metering was on. Thing is, India aimed for a lot of setting up a lot of microgrid for electrification, and this is the story in our policy document, which have been released. Now most boards were in red, in loss. So to take care of that, government brought some funds to them in 2015. But as you know that if you give free money to agencies, so nothing improved. So now they have revamped district. They said that you will get money, you perform well. Try to bring your losses 12 to 15%. So it is performance network. Now with changes, renewables and distribution and microgrids and then IT infrastructure, central monitoring unit, we are now moving active distribution network. Now, the challenge here is that the power flow can be bidirectional. Like if you have surplus power in the distribution, it can flow back. And you know that when you put the relays, it is coordinated based on some assumed power flow direction. So you go for intelligence, the up relay. So those changes you have to take care of. We are moving the participation of actually also being encouraged. Renewable of your environment poses a lot of tech. Like you see this is the real graph from India. Cloud is there, rates are there. So how variable they are. So you need very forecasting tool. That becomes a part of the system. Take their output so that you can manage the deficit or surplus from them. They are specific. Like inverter resources, which includes solar, if you connect to AC grid, they are inertia. So solar has no inertia moving part. That poses a challenge of stability. So as your energy concern, you have to balance, you have to ensure stability, you have to ensure security and satisfactory power quality and frequency, and you have to take care of the production. So more challenging to be addressed. Now, few things about solar, as I said that solar output. Time it is not there, how to ensure stability. No reactive power output is normally there. So need to use proper compensator, use all of these inverters. And then health monitoring of the solar inverter has to be ensured. This is a very simple you that how PV panel is connected. You can have, if you are having AC, then DC to DC converter, and then after to AC converter, you bring to some high voltage. If this is lower and make it 450, you need to have a little DC voltage. You can operate it at maximum power point to extract maximum power. Now, if you're talking about charging station, then this part will vanish. The fast charge. So if it is slow charge, maybe it is connected. But if it is fast charger directly at the DC bus, you can connect the fast charge because it is actually DC based. And battery energy is required during night time. So that is how we normally operate. But to take problem going for smart inverters, where sacrificing little bit of the real power from the solar PV, you can reactive power. Your real power, you are generating reactive power. Real power reactor being built, and it has been made by Central Extreme. Certain sizes of the, I think 10 megawatt. Everybody has the smart inverter, but for the inertia controls, which will also mandate. So these controllers can also introduce inertia in the system. Now to take either flex, other generators can come in the grid very fast. You can have enough storage. Energy storage type where pump is being popularly called. It was already there, but enhanced in our country. The support will come from pumped hydro. This layer has not been exploited. It is a similar principle, but storing the water, you actually store air, which is normally inside the ground. You compress it when the load is low, and then work as generator can utilize to generate the power to run the turbine during peak hours. So that's the principle. But this has to be exploited. Flywheel is not very popularly used. The concept is there. Superconductor small installation is popular. This is only for transient. Now, superconductor, because of the storage of nitrogen, producing nitrogen at low temperature, has not picked up that at that rate. Now, this will because of the hydro economy. There's a drive of the world to go for green hydrogen. And if that succeeds, fuel cell will come into picture. As the electrochemical, which includes lead-acid mature technology, matured, but problem here is that most of the lithium ion mines are lying in, and everybody has dependent on one country to make the batteries. Others are sodium based. Flow batteries are also mature. But let me tell you, one problem is the disposal, other life, which has to be overcome by new technology. Then cost is also there. So you have 3 to 5 years, you have it. Should focus more on grid and combination with the electrochemical storage systems. There are, we are going to integrate with the good IEEE 5047. Some standards have been taken by Central Electricity Authority. They also brought out guidelines for the renewables. So 2008, the main standard came, then made several. So this slide will be circulated to you whenever you want for that. Suppose I want to go for interconnection storage, then you have to refer to part 9, the distribution impacts, part 7, and so on. So very good standard list, IEEE standard for integration renewable into the grid. Now, what is microgrid? Microgrid, a lot of definitions came. IEEE 2030, which is on, has also given one formal. It says that it is the group of low resources, mostly energy resources, controllable entity, which can be connected or disconnected from the grid and can operate in islanded. There is one white paper which is very important for the this particular microgrid topic. All aspects of microgrid are covered, and I will encourage you to go ahead with this. Once you get access to this slide, it is freely available. Now, here is typical microgrid. It is connected to the main grid. Load is there with proper controllers, and sources are there like solar, wind, and battery backup is there. Now, why we are going for that? One is to electrify the remote area. Other is to ensure the security of the strategic location like defense locations. We can go for a lot of microgrids. Third one is that whenever grid fails, you need backup power. So I will just tell, because I was part of 2012 blackout committee, and we took 14 hours to recover the system. Why? Because no black start power was there. So that is required. And then also, if you locally provide the generation to the load, the T&D losses will reduce. If you go for clean energy, greenhouse gas emission will reduce. It will encourage renewable resources to be set up and meeting the net zero goal. So it has a lot of advantages. So every government has gone for promoting microgrids, including India. And now there are two possibilities of microgrid. One is AC microgrid, other is DC. AC means main bus bar. We say point of common coupling, PCC, is AC. So one side is the sources and storage, other side is the load and your utility grid. So you need proper converters to interface. Like AC-based generation, maybe it is possible to connect directly if the voltage matches, otherwise through transformer. Or if you have DC-based, then you need DC to AC inverter. And energy storage requires charge-discharge facilities, so they need bidirectional converters. Similarly, if you have DC load, then you need AC to DC. And for DC load, maybe voltage is different, so buck or boost converter is required. If you go for DC as the point of common coupling, although 750 is written here, but it's not very safe to operate. So the converter requirement will slightly change. So like DC generator will not require inverter, it will need DC to DC converter. Energy storage same requirement will be there, but it doesn't require AC interface. So there is accordingly you can design the converter. But both the grids have certain challenges. The one which is shown in green, like synchronization, frequency control, reactive power management, that is very much relevant to AC, not applicable to DC. So that problem is not there with the DC. But both of them have to go for voltage stabilization, proper power management through energy management system, quality management, production, stability, and islanded as well as grid connected operation. So controls should be there. So microgrid means you have generation, you have storage, you have loads, and you are having proper controls so that it can operate autonomously as well as in grid connected. Okay. Now there are many standards on microgrid also, like 230, 2030 IEEE is on microgrid controllers. Then interoperability 2011 standard is there. A lot of IEC, international electrochemical standards are there on microgrid technical requirement, protection requirement, energy management system. So if you are working in this area, you may have to go for these standards for reference purpose. Or if you are doing some research, requirement has to be met as per these standards that you have to verify. Now, as I said, the microgrid can be either isolated, not connected to the grid, because remote area where the line cannot go, that can be isolated microgrid, or it can be grid connected. Now, this is a new concept that two microgrids, nearby microgrid, you can interconnect. So network microgrid can be there, and they can share power amongst themselves. I'll give you one example which we had implemented. Based on topology AC, DC, or it can be combination of AC and DC. Based on power size, it can be nanogrid, which is few kilowatt. So your home grid can be nanogrid, about 5 kilowatt or so. Microgrid, micro word came because of the micro size of the big grid. So if you're talking about 100 gigawatt, micro size will be, or micro size will be few megawatt. So from few kilowatt to few megawatt come under this category. And then mini grid also about 20, 25 kilowatt, 50 kilowatt is called mini grid. There is no clear-cut demarcation, but this is a small size limited to a small geographical area. The grid have been formed at little lower voltage. As I said, microgrid offers many advantages. It can reduce the peak of the overall grid. It can help in voltage control because if you have smart inverter in microgrid, they can also support reactive power. Black start power it can provide. And if there is a natural calamity, then some part, it will not be complete blackout. The microgrid part can be isolated and they can provide the power. But as I told, a lot of technical challenges have to be met in both the grids. Now, the several microgrids can be connected to the distribution network. Now, what is the control hierarchy? Like, if I go to the individual sources or the storage devices, they have their primary control, which is a converter control. So it can be current voltage control. If you're talking about PV or the other type of renewables, it will have group control. If it is AC, MPPT control, even in DC also, because we can have PV control. The MPPT control, harmonic has to be eliminated, that kind of control will be there. But microgrid level, because you will have more sources, more than one source, you may have storage, how to balance the power between them to meet the load demand. And if you are connected to the grid, how 3 or 4 are being balanced. So that is the part of energy management system. Storage charge discharge also, you have to when to charge, when to discharge, how much level it should be charged. It should not fall below 20% of the state of charge. It should not go above 90% to sacrifice its life. Then how to detect islanding and how to manage the islanding, how to reconnect with the grid, that also control should be there. And local voltage and stability control. This is called secondary control and becomes part of microgrid energy system. Now, when microgrid is connected or directly the sources are connected to the distribution network, we go for tertiary control, which is part of distribution management system. Yeah, you can record it. I think your organizer is going to record. So it is part of the distribution management system. But if you are managing renewables, large renewables, it is you are transiting to advanced distribution management system, which includes forecasting of not only load but renewables, optimal power management, volt war control, reconfiguration. And in future, you will see that at distribution level also power will be purchased locally between two microgrids or between two consumers, prosumers. So transactive or market signal-based control will be there. Now to manage this, you require a local system operator. So the concept of the distribution system operator have been coined. So I'm not going to talk about that, but that is also part of our national electricity plan, which have been circulated. And one white paper was given by our group along with IT Delhi and Terry, which was accepted by Ministry of Power. And it was launched at MNIT actually, so a few years back. Now, there are many other standards which I mentioned, the repeated slide, I think. So you can refer that. Now, Government of India is also promoting renewables in a big way and also microgrid. So National Renewable Energy Act by MNRE came, Ministry of New and Renewable Energy came in 2015. There are many schemes to improve the condition of distribution so that renewables can be integrated. National tariff policy to encourage renewables came in 16. Renewable based mini microgrid policy came in 16. Again, various states, they also brought out policies and regulations. Like you see Bihar, Odisha, and then Jharkhand. And then if you see on this side, again, mini grid regulations are there. UP brought regulations, MP, Jammu Kashmir, Andhra. So they brought regulation as well as the policies to promote the renewables as well as the microgrid. As I said, NEP 2026 draft document which have been circulated for comment, they clearly say that use of microgrids utilizing renewables should be enhanced in rural and remote areas. Okay, so there is a clear cut direction. Now, there is a long debate between DC and AC. I mean, people, although AC has matured, because naturally AC voltage have been adopted worldwide, DC also offers many advantages because it doesn't have reactive power. So total kVA and kilowatt is same in this case. So you save in the conductor size, current carrying capacity is more. There is no skin effect. There is no reactive power requirement. Efficiency is more. You can have, because there is no frequency control required, phase control required, so better controllability is there. And then they can participate. You have to go for coordinated control for maintaining the required DCMG voltage. Now, some of the popular application you can think of is internet and telecom power systems, data center. I think this is a very big way it is coming. and they are going to be the biggest load in future. So data center supply can be through local DC microgrid, semiconductor industry, shipboard, aircraft, community level, or the military level, that the defense level, you can put the microgrid. Now, the technical challenge is that voltage and quality of power supply have to be controlled properly. Power management has to be ensured. Each module, it may be in modular form, they have to be intelligently controlled. Why we have to go for modular control? Because there is a limitation on the DC low voltage, which we can go ahead. Why is it so? Because of the requirement of your circuit breaking, which is very difficult in DC supply. Protection becomes an issue. I'll just tell you why it becomes. So carrying forward, it is more efficient as compared to AC, capability of transmitting root 2 times more power at same voltage level, free from skin effect, reactive power, less number of system components, because AC converter is not there. Paralleling of sources becomes easier here, whereas you have to go for synchronization and other requirements in AC. Easy to store because directly DC can be stored in storage system, but protection becomes very challenging because of circuit breaker technology is not there. It is being developed. Fault detection and coordination is key. Fault detection becomes difficult, and location also has to be taken care of. So why it becomes difficult? If you see AC, there is a oscillation, sustained oscillation, and slowly the fault is getting stabilized at some higher value. Whereas on DC side, it reaches very fast to a very high peak. And in microsecond, it dies down and reaches to very low value, comparable to your load current or maybe 1.5 times load current. So steady state, it is difficult to distinguish. But your protection has to operate in microseconds. That is the difficulty we have because of the DC coupling voltage. This peak comes. So that is how this protection in DC network becomes very challenging. Now, isolation of AC becomes easier because it sees the natural zero crossing. So to avoid large sparking, you can look for a zero crossing and isolate the circuit. Whereas here, there is no zero crossing. So the isolation will result into sparking if you go for very high. Now in India, for microgrid, maximum 48 and 96 volt have been suggested, not beyond that. So most of the installations we have seen is the 48 volt DC microgrid for limited applications. Now I will give you some example of AC microgrid which we have implemented as part of the Indo-US project. So this was 5-year project and 16 organizations were from US and 15 from India. It was on developing future smart and resilient distribution system, interfacing DER and microgrid controls, energy storage, and showing the optimal management of DERs and microgrid systems. And DSO concept was to be demonstrated. And there were 15 organizations from India. Kanpur was the lead. There were 4 other IITs like IIT Delhi, IIT Roorkee, IIT Madras, and the Bhubaneswar was there. TERI was one research organization which was part. A lot of utilities were there, NTPC Netra, BSES Rajdhani, Power, BRPL, UP Power Corporation, Power Grid, and were there. And few industries were involved. Their partners and one NGO was there. Because we implemented in a village, we wanted help from them. From US side, the Washington State University was the coordinating institute. And then Texas A&M, MIT, West Virginia, Hawaii National Energy Institute was there. Their national lab was a partner, Berkeley Lab, NREL, Renewable Energy, Non-Conventional Renewable Energy Lab. And that Pacific Northwest is also the national lab. And utilities as well as organizations were involved. So it was big consortium. So I was initially the overall coordinator from India side and one past president of the Power Engineering Society, Dr. Nalsuj from Washington State was the coordinator. And then after my retirement, actually, Professor Santanu Misra and also the Ankush Sharma became the coordinator. So that is how it went. Now, apart from carrying out research in almost all the areas, storage sizing siting, charge discharge controls, optimal scheduling of which is part of energy management system at tertiary level and microgrid level, converter design, then microgrid, every aspect was worked out, forecasting, then this advanced distribution management concept, transmission system, distribution system, operator interaction, and then deciding proper communication and cyber security measures, bringing out policy document, doing the impact analysis of our field installation was part of this project. So there were 10 field projects. We divided into 3 types. One was rural, second was semi-urban, third was urban. Rural actually was real village we selected in India side. I'll just talk more about that. Semi-urban were mostly in the we'll share that. So semi-urban were in the campus only, like Netra, there is a whole campus was a semi-urban pilot. At IIT Kanpur, we implemented 2 semi-urban pilots. Urban was in IIT Kanpur campus, one, and second one was in New Delhi. Actual utility was in ward, residential, institutional, and the transformer feeder they covered. Similarly, US side also one rural, 2 semi-urban and 2 urban pilots were there. So let me talk a little bit about our Indian pilots. They were all employing the AC micro. And on top of that, indigenously with the help of one industry partner, Synergy, we developed, because they had implemented the SCADA system in our campus. So advanced distribution management system, the platform we developed in Kanpur. And all the pilots coordinated by IIT Kanpur are interconnected. They are being visualized. They are being controlled from this advanced distribution management system in our campus itself, whether it is village pilot or our campus pilot. Okay. Now coming to rural, because this is a very exciting project, very challenging project. As you know that we have about 6 lakh villages in our country. 63% of India's population live in village. At one time it was 75%, now it is going down. Now it has reached to 63%. 2018 PM Modi, he declared that all the villages are electrified. But fact is that although wire has come and transformer has reached, some of the hamlets are fully electrified, but there are many hamlets which are not still electrified. Hamlet means that a big village has group of houses which are separated from each other by a few hundred meters or kilometer, but it is part of one panchayat village. All of them are one panchayat village, but they have different identity. So, and then reliability of supply was relatively poor. They brought out microgrid policy, but few states also, as I told, have brought out the policy. So UP had already had that policy. Then many private sector, Tata Power, NGOs, they had set up rural microgrids, and ministry is also funding partly to go for microgrid. So looking at that, we decided that we'll set up in one of the microgrid rural area, because we are in Kanpur, so Kanpur village we actually surveyed. Let me tell you how did we proceed actually. First task was that where to set up. So we went several villages, found 2 hamlets in one village having 85 and 75 household, about 750 people were there. And then we found that they are not electrified. No wire has reached to those hamlets. It was about 45 kilometers from our campus. Then we tried to have meeting with the help of our NGO that there is a need to go for local microgrid. You can have your own resources so that you get electricity. Lot of resistance was there. and somehow we could convince. Finally, they agreed to go ahead with that, but then they said that more than electricity, you just see the mentality. They have not seen electricity. They say that more than electricity, we need the irrigation power. Because they had no electricity outside the hamlet, there was one pump from which they were purchasing at a very high rate. So we approached the funding agency that we want to provide them the solar-based pump for irrigation enhancement. So they agreed. So we have installed 6 solar pumps. Now, once we have identified, the question was that what is the size I have to go, what type of supply we have to go. Irrigation, solar irrigation was there in both the villages, very good solar potential was there. But we found in one of the village, lot of cattle are there. And cattle waste is lying on the road. I mean, it is a street. They are poor villages, but it was becoming very dirty. So they were not able to utilize it. So we thought that we'll go ahead with cattle waste based biomass. So in one hamlet, we went for only solar with battery energy support. Other village, we went for 30 kilowatt solar and 30 kilowatt biomass with battery energies. Then we requested our local utility partner to provide transformer and also electrify their houses so that we can operate independently these two microgrids. We also thought that let us interconnect them. So it became interconnected microgrid. So that we depend less on the electricity board, minimize their expenditure to electricity board. And locally, if they have surplus power, they can share between each two. Now, since it was AC microgrid, the question was that how to synchronize them. Very difficult. If you are electrical engineer, you know that it's not possible to synchronize unless you have some source which is controllable. So, and compared to the grid, it should be controllable. So we went for AC, DC, AC interconnection. So that is the background. Then we did a lot of R&D, basic engineering, and then what will happen? We have also decided what type of protection, what kind of metering requirement is required. So simulations were done. How to sustain it? After the project is over, I think they will destroy everything. So local society was formed, governing, consisting of majority of people from Panchayat. And then one member from the NGO, 2 from IIT Kanpur is part of that, 1 from electricity board. And then agreements we have done for solar water pump distribution. Another society have been formed. For the biomass, manure management, who will bring the cow dung. And because one of its output is the very good quality of manure. So who will sell? So local body have been formed. Okay. They were quite poor. So we also thought that we will set up some cottage-based industry because the electricity will now be there. So agriculture-based cottage industry also we have set up. We have built one building and we have set up. And finally, we did the post-impact analysis. Now, this is the pre-installation scenario. See the middle slide? No wire is there. A lot of cow dung is lying. This is one of the hamlet Bargadiyapur. Other is Chabba Nevada. Okay. Chabba Nevada. So that was the situation. There were very small size solar installed by one of the NGO with only 2 lights and 1 charging. And if you see the rate, okay, we'll see. MNRE has a policy, you can go there. So you see they were charging at 100 rupees, almost 100 rupees per kilowatt hour. I mean, because the total amount was less, but we calculated it was 100 rupees. And that was one reason villagers registered that if I go for solar, my electricity charge will be high, although they had not seen the electricity. So at one time, I think near this tree, I had a gathering and I said that if it goes beyond your electricity board price, you hang me here. And they were all silent and finally accepted. And then land acquisition was also a problem. We had a lot of initial meetings This is first meeting. I am there, and our colleagues are there. Ladies and gents were there to convince them about this project. And then finally, groundbreaking. This is myself breaking the ground took place. And then when bylaws were formed, local society was formed. Again, panchayat meeting was held. Electricity board, they installed transformer, brought the wire, and connected to their houses. So this is the structure of microgrid. So both are grid connected. They had provided 63 kV transformers at the two, 11 by 415. And then through microgrid was connected to their homes. Remember, many of the villages do not have street light. So we also provided street light. This particular village had one school, very up to primary level school, but no electricity. So we gave one wire to them. Then solar pumps were installed. And then this is the AC DC AC converter to interconnect the two microgrid. Now, this is very unique model we have given actually. So about 700 people are getting benefited. Now it is continuous supply, and if there is a power failure for 5 minutes, they call IT Kanpur, why I am not getting. So you remember they have not seen electricity for a long time, but now they cannot tolerate 5 minutes power shut off. So, but a lot of challenges were there, which we overcome. This was a really challenging project. I'm very happy that it is working very nicely. This is post-installation. This is biomass. So biomass power plant. There are some training program also we gave to villagers about biomass system, how to operate. We have employed their own ITI graduates for operating the system. So we have not taken from outside. These are our review committee. This is solar pump we have installed. This is solar installation in one of the hamlet control room. And similar building is there as the processing unit where their cottage industries are installed. And then control room is built. Again, whenever a training takes place, we take them to the rural microgrid. Now, semi-urban, as I said, inside our campus, we had two semi-urban pilots. Sorry, one semi-urban pilot. It covers, because semi-urban means you have semi-urban area, you have single or two-story maximum, so you can go for rooftop installation. So in our campus, 2 lanes which had single-story houses, 30 of them we have put 5 kilowatt solar, and we have gone for centralized storage. So we did optimal siting and study, and then decided to go for centralized storage. So there are 2 feeders going. They are interconnected, but normally it is open. So now 2 batteries are there, like 140 kilowatt hour, 100 kilowatt hour, and there are 30 solars, 5 kilowatt hour. Not every house was site for solar installation because of the tree and other obstructions. So only 30 houses were set. And all of them are controlled through microgrid energy management. So this is our battery backup, battery energy, lithium ion battery. And this is the house where the solar have been installed, typical house. And that is how it has been interconnected to the inverters. And charging station also, we have gone for 2 in numbers. So 2 charging stations. One was fast charger, 50 kilowatt DC, 22 kilowatt AC, 7.6 kilowatt, which is vehicle to house capability. And then 3 for auto rickshaw charger. And since the theme is how to make small microgrid here, we had installed 25 kilowatt solar locally so that they don't take power during daytime from the grid. But if you want to make it sustainable, you have to connect a storage here. So local DC microgrid. It was AC microgrid, but DC microgrid can be formed. So that was one semi-urban. Now, urban, there are 2. One was in a multi-story, because in urban area you go, the buildings will be taller. You have to go for rooftop solar installation on the top for the whole building. And then the battery have been installed. Local battery have been installed. And then we have connected them along with battery to the through hybrid inverter to our main distribution board. This is the battery storage we have. Now, this during that time it was enough to supply the whole building because the 25 kilowatt and then battery storage, and even if power goes, it was enough to supply. But during night time, when solar is not there, battery cannot sustain the complete load. So what we have decided that we will operate the lift load and also local lighting load, which was being fed from the diesel generator. So use of diesel generator have been avoided. Second part of the project was on one of our institutional area building, which was a green building. This building had thermal energy storage. I'll tell a little bit about that. Thermal energy storage actually operates. It is having glycol solution with phase change material inside, and it is connected to the chiller plant, main chiller plant in the building. The idea is that during night time when load is not there, it will take chilled water and bring down the temperature to -6 or -10 degrees Celsius. And then during daytime when it supports the air conditioning. Okay. And the whole schematic of this have been replicated at our control center. So we can see the position. We can also know what is the temperature. So this was also another very unique installation, and which is applicable to most of the buildings, high-rise buildings for air conditioning support. So it already had similar plant which was having underground tank, but this new tank was also installed, which is of about 545 ton hour. 230 ton hour was the existing one, but not operational. That we also made operational. So 775 ton hour. That means if you have a load of 77 ton building load, then it can run for 10 hours. Okay. And the peak load is 150, which never comes. The average load is about 75. So up to 10 hours it can support. One charge can support. I don't think it has stopped. It has continuously running from the 2020 and very satisfactorily it has been operated. Now the person who is inaugurating is Professor Karandikar, who is now DST secretary. And we are standing here. So you can recognize some of the faces. Now, this is how the impact we saw after 2019, when this plant was not there, the energy consumption was little higher. 20 was Corona period, so building was closed, so we did not record. But 21, most of the time, the energy consumption has gone down. Okay. So overall benefit it has provided. Now, we also built our own the indigenous advanced distribution management system, as I told. It had certain unique feature that it was plug and play structure, a CME interface was there. We already had SCADA on top of that, to connect the meters and other devices. We have enterprise service bus we have provided. And then it performs many tasks like complete system. You can analyze what is the state, power flow it can perform, fault location isolation, volt warren optimization. By the way, we had also put the smart inverters. They also participate in volt war control, loss minimization, and then it has geographical information system. You can see the cables, where it is going, what is the status, outage management, weather forecast, and load forecast we are doing. It is being used for training purpose also. This is one of the typical diagram we get on the display. So I will encourage, if you are there, you can visit that. And all three pilots, other four pilots, urban 2 and semi-urban 1 and rural, they are interconnected to this centralized system, which is ADMS, but locally they are being controlled through microgrid energy management system. Okay. Now, as one of the partner, Terry also went in Delhi's, okay. Delhi actually, in Delhi city, they have installed the batteries. They have demonstrated the use of batteries in different settings. Like one of the transformer was getting frequently overloaded. So to avoid overloading in one of the feeder in Delhi area, local utility BRPL and Terry had installed storage, and so that it need not be replaced because of the frequent overloading. So overloading is being avoided. So local energy management system are designed, and then whenever the loading reaches 90%, the battery comes into picture, and then overall saving in power purchase and DT life has increased. Second was in a group housing where backup power was DG, diesel generator, so they wanted to avoid its use. So storage they have gone for, and optimally they have rated it. Third one, this is in Dwarka area, and this is their own Terry campus where they had solar, but nighttime it was not operated, it was not dispatchable. So with the help of battery, they made it dispatchable, and many other new things they are trying out, like energy time shift, the peer-to-peer trading exercise they have done. So these are the three installations in Delhi city, actual Delhi city, with Terry and BRPL has done. Netra went for a very big AC microgrid. They already had a DC microgrid of a few hundred kilowatt. And then whole campus they wanted to make self-sustainable. Ultimately, right now it is connected to the grid. So they went for 4 megawatt hour solar and 1 megawatt hour lithium-ion battery. They also had municipal solid waste generator, which they have connected 400 kilowatt. So solid waste from canteens and nearby area, they bring and then generate the electricity. So it is a waste utilization also. They have recently also installed the fuel cell. So the fuel cell also is being hydrogen-based fuel cell that also they have interconnected. So main idea is that the dependence on the grid is minimized, and they also develop their own microgrid controller to satisfactorily operate it. So a grid connected mode is operating very satisfactory. It's a huge PV installation you see in a farm like situation, because it is 4 megawatt hour. It is there. Okay. So these are some of the AC microgrids which were developed under our Indo-US perspective. Now, there are several DC small microgrids existing in the country. At village level, house level, as I said, that charging and they are the DC microgrid. But CDAC Trivandrum actually has developed few physical DC microgrids as part of their RAMPET program, where I am actually reviewer. So first of all, they came out with a general architecture for home applications and developed various power packs, energy management controllers, communication requirements they worked out. And this is the conceptual diagram. So power pack, we have Zigbee, another interface, protection and distribution panels they had designed. They have standardized more or less AC to DC converter and then solar MPPT controller, battery interface. At individual houses, they have gone for the intelligent control so that they can participate in energy management. So room controllers are there. So this was the conceptual. In some of the buildings, they have already made it operational. It was 48 volt DC. Higher voltage we don't go because of the safety reason, security reason, and lack of isolation and protection devices. So they have not gone for that. Then they also said that they can interconnect with any type of source, solar PV or micro, wind, fuel cell, biomass, or utility grid, and this side any type of load, DC loads or battery energy management system. Now remember that TV inside or many of the electronic gadgets have DC requirements. So directly it can interface with them with proper buck boost converter. Now this is very interesting project long back they implemented in a village. It is a tribal village. The pictures are a little smaller, but this is the village where they have put about 25 kilowatt solar with a 300 ampere hour battery storage, 48 volt it is operating, and then telecom tower. This is very isolated area, so the electricity cannot go there. So, and it is tribal area. very underdeveloped, poor people are there. So they have gone ahead with that. It is in Kerala actually. The place is actually is written here, Marayur, Idukki district actually. So it is inside forest. Actually, I traveled. There is no road. Very scary road is there where you go in jeep only. There is no other access, and you feel like that anytime you will fall. So we went there to review that project, and very interesting project. They are very happy. So they have provided a street light. They have provided access to their home. One telecom tower they have energized so that they can get the telecom signal. So this was one of the project. Now, as extension of this project, nearby villages, they have gone for similar installation and they are locally they are interconnected. So that is going to be commissioned very soon. But that is combination of AC as well as DC microgrid. So this was pure DC microgrid. Now they have different type of applications. Like houseboat people, they run their diesel generator, a lot of pollution is there. Kerala is very popular in the lakes for tourist purpose. So they wanted to replace by the electric systems. So one requirement was their propulsion system for running the motor where diesel engine is conventionally put. So that they replaced by motor and solar, very special type of folding type of solar they have put here. And then they have for their room loads, hotel load they call, it is being used and also for running the propulsion system. Today only we had a final meeting on this. This is going to be in operation. It is already in operation. Testing stage is there very soon actually. So boat owners have given their boats and local body is coordinating. So this is also one of very interesting project that they had. Again 48 volt DC. Now, second one was in one of the buildings, 5-story building, which is owned by the Kerala Development and Innovation Strategic Council with 20 kilowatt solar installation, but they have divided into modules. Now, like floor 1 is one cluster, floor B 2 and 3 is another cluster, floor 4 and 5 is third cluster, and modular connections they have gone ahead. Okay, because they don't want to enhance the voltage and current in a DC system. And then lighting load, fan load, computer load, air conditioning load, they are feeding through this system. So export of energy, they are minimizing. Grid export, they are import, they are minimizing, and export of energy, whenever the local load is not there, they are also giving supply to the local electricity grid. So net metering is also there. This is also complete and running very satisfactorily, this particular project. So these are just 3 examples of DC microgrid I gave. So finally, to conclude, I would say that, I mean, our grid is changing. Earlier, grid concept was limited to bigger grid. Our 220 kV and above, the SCADA system was there, has been there for quite long time. That is what we call the grid, main grid. But now with renewables coming up, distribution, microgrids being formed, now there will be seamless grid up to consumer level. I mean, consumer also can be a supplier, because if you put on your solar rooftop, then you can also supply whenever you have excess of generation. So microgrid are being encouraged and large numbers just to feed remote areas, community level electrification, or some of the plants, they have their own microgrids. Like we saw that Narora, our nuclear power plant, during blackout of 2012, they had their local microgrid operating. And the electricity grid took the help of that power, remaining power, to restart the generators. So strategic locations, defense locations, it is being. Now India is mandating at remote and the village level at least to go ahead with microgrid formation. So AC microgrid has matured because of the advantage of the consumer gadgets, production control technology, and energy management concept is already there. But DC microgrid will become popular once we overcome. One of the major problems is the production and isolating device. If we overcome that, then it will becomes feasible. We can go for higher voltage at least. Now it is very interesting that 2008-9 I was in US, and US naval shipyard. This was war shipyard. Warships. They used to carry a lot of weapons in that. It was very secret project, but I was also part of that. Many universities were working on that. So they said that they will form, the ship will be electrified. Will not go for diesel. And three things they said, different parties were working. One was pure AC, at 60 hertz, their system they had. Second, they said that let us go ahead with higher frequency. Higher frequency means equipment size will reduce. And explore that. Third one was DC microgrid. So DC microgrid, again, they said, but 7.5 kV. So a lot of industries came to develop breakers, like G came. And the production system, they came joined together. It was R&D project. So why I am saying that their naval were so advanced that they are seeing that in future this kind of system will come. So we worked out, comparison was made. Finally, they did not tell what kind of system they will go ahead, because at least foreigners, they will not allow to share the information. So that kind of strategic locations are, because why they wanted to go for DC and high frequency, because to minimize the equipment weights, so that they can carry more weapons. So that kind of thing, I think India also is maybe thinking of in that direction. Or Indian level also need to develop in that. DC microgrids, protection as I said, and use of higher voltage becomes an issue. Large deployment of microgrids will require converter interface, controls, energy management has to be designed. This will be tailor-made design depending on what kind of sources, storage, and loads are there. So it has to be conceptualized differently at every place. You have to select proper communication, like long distance, and like if I'm communicating 45 kilometers from my village, I cannot have Wi-Fi connection. So I have to go for this mobile connections. I have to go for lease line and then go for mobile connections. Once you have communication, then you have cybersecurity problem also. So that also have to be addressed. Security and stability of system has to be ensured. So that's all from my side. I would like to acknowledge our students, faculty colleagues, and UIS project, and Mr. Ravi Joseph from CDAC. Last minute, he gave this input about DC microgrids. And if you permit, do you have any question? Hello, am I audible? Can somebody confirm?
Yes, sir, you're audible.
So do you have any question? Otherwise, I'll show you one video, which is 10 minutes. Can I go ahead?
Yeah, yes, sir. Please, sir.
Okay, let me see if this works. Okay, I have to escape. Yeah, this is our Indo-US project video. Initially, it was made, so you can just see a glance and then, is it audible?
Not yet, sir. Please play the video.
So it came in two phases. Second phase you are involved.
increasing the use of connected devices. The aspect of the use parallel student plus the
Sir, is there any question, please?
Yes, sir, there is a question.
अनुपम, ये म्यूट करो, आवाज कहाँ से आ रही है? सर, there is one question.
Say, like all this, is one thing. Just the that's the game of what we see that I have us is not yeah, that's the other parts. Another part is just the increase of time. They along with the RDF. Also, the utility we paid by the sense, the use the only contents we paid working with Steve this along with what we did plus. Set up the biggest exchange was is by the
Video is not visible to us.
On Sunday of the island, like Texas, and the state on this and they have this on that way. The state, the local utility, and the factory for the stations. Getting violation there.
Okay, I just stopped. So is there any question? I think there were some questions.
Yes,
Hello?
sir. In chat box. Yes, sir. Thank you, sir. So there is one question in
I think there are a few questions. I think somebody wanted to ask.
Yes, sir.
Mrigant.
So it's in chat box, sir. I'm reading. Hi, I'm Mrigank, one of your old student, 13 to 15 MTech. Want to ask, sir, could you please explain difference between secondary and tertiary control? Is my understanding secondary is plant level, is tertiary between plant?
So secondary and tertiary control is at microgrid level. Like microgrid will have the solar, wind connected to feed the local loads and also storage to sustain it. So source and resources and the load control, or if it is connected to the main grid, is done by microgrid energy management system. That is the part of your secondary control. Tertiary control is at distribution level, which is called distribution management system. So you may have several microgrid or may not have microgrid connected, but a lot of renewables are there connected directly to distribution feeder. So you are doing energy management there and also doing forecasting, the power management and so on. So that is the tertiary level control. I hope I answered your question.
Thank you. Sir, so these boundaries are like firmly defined or sometime at boundary level is
Yeah. So DMS and ADMS is tertiary control. Microgrid energy management system is the secondary control. Most of the time when you go for the microgrid, I mean, if your controllers are purchased by somebody, I suppose you gave it to some industry to install, like in our case Siemens installed. So they gave their microgrid energy management system. But logic were decided by us. Actually. The whole overall energy management system logic was decided. Whole operating philosophy was decided by. Like how to charge battery, when to charge, load management, what will be the priority of sources. So that was decided. So they implemented, they coded it.
Okay.
So it is local to the microgrid, whereas the local utility control center will have your tertiary control. Okay.
Like
That
say
is
group control is part of secondary control then.
pardon me?
Group control is part of secondary
Group
control.
control is part of secondary control. Yeah, but that group control is actually inherent with your controllers. Even can be part of power control also.
Yes, sir.
The primary control also. Yeah. Maximum power point tracking, group control can be part of that. Yeah. But coordination of group control will be through secondary. Yeah. Secondary has some optimization problem with constraint like SOC. Yes, it will have optimization, yes, because both secondary and tertiary will have different type of optimization. SOC also is seen by the secondary controller within the microgrid. But if directly a storage is connected to the distribution network, then SOC will be ensured in tertiary also. I mean, the boundary of secondary is actually the microgrid. So that is how it has been distinguished. Anything else?
So there is
But
one
it
more.
will have optimization, yes.
Do we have a case study of residential society for a volume of 300 or more number of flats with DISCOM disconnected anywhere in India with RE and microgrid? Like only isolated, everything is isolated, not connected to grid. So is there kind of a study somewhere?
300 or more houses. I'm not sure what kind of houses you are talking, but I mean the local area, is it? 300 or more houses. It can be very big village or it can be one area of urban system.
Within
So,
urban system,
or it
yes.
can be a campus actually. Campus
Camp.
microgrids are like
Yeah.
examples of campus microgrid.
Yes.
Actually, worldwide, if you see the Illinois Institute of Technology, they went with campus microgrid very early, and they were self-sustaining also. So, residential apartment
Flats like these
flats.
300 flats.
So it can be done. I mean, conceptually it is same actually. So the size doesn't matter. Conceptually it is same. Unless each house has the flat will have the centralized solar and storage system. So that will form the microgrid. So conceptually, whatever we have demonstrated in 75 houses, housing complex, it will be same.
So, sir, basically, I think the question is here, like, can we go completely isolated without connecting it to utility grid and we can survive on
If you have enough generation, yes.
so
You have
officially,
enough generation, otherwise you have to go for load shedding. That is part of load management system.
so means like government policy matters, etc. There is no requirement that we should be connected or this housing society should be connected to grid if we can sustain ourselves.
No such requirement. You have to take permission actually to operate in isolated mode. Then the whole society is a single consumer for them. Single point metering will be there. So you have to take permission that I can feed you the excess load, excess generation, and also take power whenever required. Yeah. So that agreement is already, like if you go for house installation these days, you have to go take the electricity board permission if you go for net metering actually. But there is no need. You can isolate and do it. Yeah, Naren is raising hand.
Yes. Okay, so before that, yeah.
Naren, is it in chat box?
Yes, sir. Question is in chat box. Yes, sir.
Residential apartment flats, that is what I said, yeah. I mean, conceptually, whatever we have implemented in our one of the urban pilot is same actually. That is residential apartment flat.
Okay, sir. Any other questions, please? Okay, so there is no more. In some data center requirement, the load is very fast charging. Few seconds change to
Some data
megawatt.
center, the load is very fast changing. Few seconds change to megawatt overload. What kind of architecture can? Yeah, there is a special issue of power and energy magazine addressing the data center power supply requirement. I will encourage you to see that. Okay, if you are IEEE member, you get free PS member. So this is going to be future challenge to every country actually, data center load, because it is going to be huge load. The futures create. Now, right now we had air conditioning load, but now the data center load is really going to grow. So that is why people are thinking that they will form local microgrid or local sources they will put in microgrid. But here I will tell that even the power supply requirement has to be worked out by the power electronics people have to suggest more efficient way of supplying power to the data center, and also going for some kind of power management within the data center. I'm sure that will be going ahead, but it is going to be challenging. Yes, it's going to be very big load. Okay, so please go through that. I'm not expert in that, but go through that. They have shared their country's experiences and policies, but this is one area which is being discussed everywhere now. Data center. Even in our national electricity policy, they have talked about addressing data center requirement, which is the draft document which has been circulated, 2026. So, yes, that is very important.
So thank you very much, sir. With this note, I'm very much thankful that you have shared a lot of knowledge with all the participants, and definitely we
Yeah,
all.
but if you have any query, you can send email. I think you will be sharing the presentation to them, is it?
Yes, sir. We will share.
Yeah, so you are most welcome to write me through email. I will try to respond. Okay.
Thank you very much, sir.
Okay, thank you very much. It was really nice meeting all of you. So the 29 attendees only, 29 are there, I can see. But best of luck for rest of the course. I'm sure that it will give a lot of benefit to all of you. Thank you very much. Thank you very much, Marwan. Yeah,
Thank you, sir. Thank you. Well, so we can have a 5-minute break. Our next speaker is with us, so we'll start in 5 minutes. Thank you.
Ma'am,